Okay, so we're going to do the last section of the lithosphere, the last key question, which is going to be 2.5, resources. So this is going to be anything that comes out of the Earth, and let's get started with 2.5.1. The lithosphere, different types of resources. These are going to be non-energy type resources, and then the next key question we'll be talking about ones that give us our energy. So this one's going to be more material resources. All right, resources are anything we as humans end up using to our benefit. Any material we use, from your iPhones to pencils, plastic dishes, tables, anything, your computers, everything has its origins upon the earth, right? Everything comes from stuff that's inside of the earth. So it's kind of interesting to think about that because we think a lot of things as being man-made, and yes, they are, but everything, you can't just make up a material and have it come out of thin air. It has to come from the earth. We tend to focus on energy resources, but it's important to look at all of our resources and see what we're doing to deplete our resources everywhere. The life cycle of a resource leads to huge environmental implications, so we don't want to just look at the cradle. We don't just want to look at the beginning and where we get these products at, but what happens when we get rid of them? Where do they go? How do they get back into the environment? Because when we throw something away, it also goes back to the earth, but not in the same way that we got it out of the earth. So we're going to look at the different types of non-energy resources and these ideas before we delve into energy in the next section. All right. So non-renewable resources. Non-renewable, what it means is that it is a material we use that's replenished slower, it goes back to its original form, slower than we use it. Therefore, once we use it up, if we use it all up, it's going to take a long time for it to come back to its original state, probably longer than we'll be alive. So often thousands to millions of years. So one problem, and it's not just coming back physically, it's also economically. Because, for instance, with coal, not so much coal, but with oil, there's going to be, once we economically run out of oil, available oil, there's going to be not enough oil that we can financially get where it makes sense for us to use it. It'll be trapped in different places that won't make sense for us to be able to get it. So it becomes economically unviable. So it's economically and physically unviable. Many of these materials have their base in minerals, and minerals, what they are, they're deposits in the Earth's crust that can be extracted and made into useful products and processes that provide economic benefits and jobs. That's your standard definition of what a mineral is. Basically anything we take out of the Earth that's economically viable. To get minerals out of the crust, they must be extracted, usually with some kind of mining operation that we're going to go over. Examples of non-renewable resources include coal and oil will make plastics as well as gasoline, natural gas, and metals like aluminum, copper, and iron. There's different types of mining, and you do need to know about the different types of mining, and each of them has their own environmental disruptions and hazards. There's scarring and disruption of the land surface, loss of rivers and streams due to movement of sediment, pollution of the water and the air due to movement of sediment, equipment and chemicals used, impacts on the aquatic life due to runoff and large amounts of solid waste that needs to be stored, and many more things. All these things happen with mining. Basically what you're doing with mining is somehow you've got this mineral that you need, and it's trapped within the earth, and you have to get it out. So to get it out, you'll do things like disrupt the land surface. You'll dig into it, or you'll dig under it. You'll do something to disrupt the land surface and take something that may be naturally held together and break it apart. Then when you move that sediment, you can actually muck up rivers and streams, and you can pollute the water and the air and all these types of things that we talked about. You really need to watch this video. This video is great at explaining the different types of mining, so please go back to the blog yourself, watch this video. This video is huge at showing you the different types of mining, which are things you do need to know. So as we move on, we see that MEDCs are going to have strict environmental regulations surrounding mining, and so this will oftentimes make it unattractive for companies to go and mine in MEDCs. So usually we'll have to, in an MEDC, if you're going to mine, you're going to have to restore back to its natural setting. LEDCs may not be able to impose these types of regulations, so many companies based in MEDCs will outsource their mining operations to LEDCs to avoid the cost of the environmental regulations. Sorry about the camera there. All right. So even though they use way less of the resources, many LEDCs are affected more harshly in terms of the environment than MEDCs when it comes to mining, because they can't enforce the regulations. Now, not only do the mining operations themselves have harmful impacts on the environment, but turning the materials into the products and their use and disposal also contribute. So this is referred to as the life cycle of a product. So we're not just talking about the extraction, we're not just talking about the disposal, we're talking about all of it together. So we extract, then we process, we design, we manufacture, we distribute, we use, and we dispose. All of those different things take energy, they take raw materials, they take water, they use all these different things that end up putting strain on our environment. So this is where, and don't forget, each step in here requires transportation, which both pollutes and then also disposal requires land use and will pollute not only the land but the water as well. So you think about it, right? I like to talk about trash in here. We don't tend to think of when we put stuff out to the curb where it goes, right? We put our trash out and it's just gone, but it goes to a landfill and it stays there. And they dig giant holes in the ground. And if you think about all the people that live here and how much trash you produce in a week, and then multiply that by everybody, that's a lot of trash. And we got to store it somewhere. And when we store it, it can leach into the ground, it can run off into rivers, it can do all kinds of different negative things to the environment. So minimizing our amount of landfill waste, which is what it's called when it goes out in the trash, it goes to the landfill. Minimizing that amount is huge. Also, the extraction, minimizing the amount that we actually rawly extract is huge as well, which is why recycling is so important. So let's face it, we can't get around using products, though, that require materials from the earth. We got to use them. That's our lifestyle. It's what we do. We can, however, minimize the impact in the environment by exploring different types and uses of those resources. So first, let's talk about renewable resources. So we talked about non-renewable. You use it faster than it's replenished. Renewable resources are able to replenish as quickly as they're taken out, or may not even need to be replenished, like the sun as a resource, as a heat resource, right? We will get into much more about renewable energy resources in the next section, like solar and wind, but there are renewable resources we could try to utilize to lessen the strain on non-renewable mentioned above as well. The major advantages of renewables is that basically you get unlimited use, and it's sustainability. Right? Most do not pollute or produce greenhouse gases at near the rate of their non-renewable counterparts, and processing is minimal to none in comparison. Timber, wood, all right, providing wood and paper is a renewable resource, but it can be taken out renewably. So it is a renewable resource. Trees grow back. But if you clear cut a forest, if you take out all the trees from a forest, or maybe you have a farm and you take out all the trees, there's nothing that's going to then replenish, because you're taking away all the nutrients from the falling leaves, you're taking away the root structure that holds the soil together, so you're basically killing the entire area. So you have to harvest things like this, like trees and different living renewable resources. You have to harvest them sustainably. Freshwater is another example of a renewable resource, but again, and we do this, if we draw out water faster than we put it back, it becomes unsustainable. Biomass and air are also considered to be renewable. So that's the best type, but then what's recycling, right? Recycling, we've all heard about recycling. We do recycle. We got those big blue cans that we put recycling in. But recycling is basically when you turn products into other products made of the same material instead of disposing. Recycling both renewable and non-renewable resources has major advantages. For any material Not having to extract or cut down saves the amount of transportation and processing that's used. Also, you're not disturbing the land anymore. So if you're recycling, you kind of go back to this chart, all right? And if you're recycling where it says extraction, you're cutting that big boy out. That's huge. That's huge to be able to take the extraction part out. Saves your land, all right? No restoration needed because you are now recycling. You don't have to go and dig that out of the land. You just have to go to reprocessing. What else does it do? It totally minimizes that disposal aspect. So all that landfill space is huge. So you're cutting out the beginning and you're cutting out the end, and instead of making a straight line, you're making it a cycle. That's why recycling is so advantageous in most situations. And there will be people who tell you that recycling isn't worth it in terms of its energy cost. And sometimes with like paper and some different recycles, yeah, it takes a good amount of energy to recycle, but it's either going to be equivalent or less in most cases than the energy caused by extraction and disposal, but more about the energy use, more than the energy use. What you've got here is you've got the less land disturbance and the less disposal that you're going to have to do. You have to look at the entire life cycle in order to see what the advantage of recycling is. And in most cases, recycling is super great, right? In fact, there are some also that have huge energy savings, right? Aluminum recycling saves 95% of the energy used in the processing from parent material because it takes so much energy to process aluminum from the beginnings, from what we call the ore, all right? The following diagrams really hit home on some of the many recycling advantages. You can see some of them here, all right? And I'd like you to look at these graphics. What does recycling do? Reduces energy consumption, reduces pollution, reduces global warming, reduces the amount of waste to landfills, like I said, protects the environment, creates green jobs, conserves natural resources. Plastic is, plastic is something we're addicted to. I mean, there's so much of what we use is made of plastic, and plastic comes from oil that we extract from the ground. But there's major advantages to recycling plastics. Okay, so we're not going to get around using plastics. I would really like us to minimize our plastic use. Not so much from the extraction point. Oil is it can be pretty tough to extract, but mainly that's going to go with the energy use because we use way more of it for energy than in cars than we use for for things. But plastic, the bad thing about that is when put in a landfill, it just doesn't degrade. It takes 1,000 years from one plastic bottle to degrade in a landfill. All right. 100,000 marine animals are killed each year as a result of plastic bag pollution. That's a lot, right? Enough plastic is thrown away each year to circle the earth 4 times. Every minute, 1 million plastic bags are used. Less than 1% of those plastic bags are recycled. But what can you do with plastic? 5 plastic bottles can make a polyester t-shirt. 5 plastic bottles make a fiber fill for a ski jacket. All right? And we can see some stuff about aluminum. It takes about the same amount of energy to make 1 new can as it does to make 20 recycled cans. That's a huge jump. And you can see the different things on here. So there's a lot of great recycling tips on here and why we should recycle. So those are huge. If somebody's arguing with you that we shouldn't recycle, these facts and figures are really, really good at explaining why recycling is advantageous. And it's basically just science, right? And it's a little bit of common sense. And economically, it sometimes doesn't make the best sense. But when it comes to resource saving and land saving, it's going to be a huge advantage to do that. There are many different ways to look at the environmental problems associated with resources mainly caused by exploitation of those resources. While recycling is great, it really does make a difference. If you remember back to your elementary school days, you probably heard the 3 R's, reduce, reuse, and recycle. Well, reducing and reusing are even better than recycling. And I know we talked a lot about recycling there, but think about the easiest one, reuse. All right? You've got a plastic bottle, you fill it with water, you drink it, or maybe it comes with water, you throw it away. How about reusing it? You just cut one, if you're going to keep drinking out of plastic bottles, just reusing it one time, you've cut that use in half, all right? So reusing things, and there's many different things, and it used to be like 100 years ago, if you talk to, or 50, 60 years ago, if you talk to your grandparents, and you talk to them about their parents, they usually bought things that would last, right? And now we're just so disposable that we consume, we throw away, we consume, we throw away, we consume, we throw away, and it's really putting a strain on our land use. It's really putting a strain on our landfills, all right? So reuse is a good thing, saving up for things that are sturdier, that are going to last longer, so that you can keep reusing them, and thus then reducing our consumption, right? So what are some examples of that? Things at home, like using an old vegetable can as a flower pot, using the gray water from the shower to flush the toilets, using shipping containers as buildings that people are doing. They even use this for some Starbucks places. People can get very inventive when it comes to reusing. Reducing is the most simple, finding ways to reduce the amount of resources we use by making our processes more efficient. And like I said, we've become basically a disposable society. Plastics are very cheap, and it really does come down to plastics. And we really need to get back to sturdy things that may cost more upfront, but save money in the environment in the long term. So if you look at this graph, this is a good graph that shows basically what happens to a resource. So the red line is where you just mine something, you use it, and you throw it away. Basically what happens, and what you've got on the y-axis is going to be your production, and your x-axis is going to be time. And so you can see it has a very short lifespan. You use it, it gets used a lot in the beginning, and then it's going to deplete because you're going to have less of it, and it will basically go away. We can extend that resource by having recycling. It increases the reserves, all right? You recycle, but you still have to use some parent material, and you're still going to have some landfill waste. And so your depletion time gets stretched out a little bit, but you can do even better. But if you use the 3 R's, recycling, reuse, and reduction, you're going to increase the reserves, you're going to not have to mine as much, better mining technology, and then you get new discoveries along the way that extend the use of that resource. All right, other than reducing and reuse, some ideas to some ideas to reduce resource consumption are decreasing waste at mining sites, increasing environmental standards for our mining operations, decreasing subsidies, and subsidies are where the government gives kickback or basically tax discounts to companies for mining operations. So decreasing those if they're not environmentally friendly. If they're environmentally friendly, increasing them, all right? Increasing subsidies for reuse and recycling, more efficient manufacturing processes, biomimicry, which is where you copy nature's processes, recycling waste or energy to use in other processes. And so that's a really cool one, recycling the waste or energy to use in other processes. And so you can see some of this here, where you use the waste from one process to fuel the other processes. I just saw a great documentary, it's called Blue Wave, I believe, on Netflix, where they're talking about this. They're talking about how algae is a huge problem. We're going to talk about this later. And in wastewater, algae is a huge problem. They usually just try to kill it. But there's a place that is, I forget which country it is, and but they are actually taking that wastewater, the water after that comes out of the toilets and the showers and all kinds of stuff. They're taking that as nutrient-rich water, and they're actually growing algae. They're going to separate out the algae, and then they're going to use that algae, and they can use it to make biofuel. They can use it to make fertilizer. They can use it to make all these different types of things instead of just trying to kill it and throw it away. So it was waste that they were going to spend time and energy to kill, which they're actually just now separating off and then turning it into something profitable. These are the types of ideas we need to do. All right. So, for instance, here we've got some more of those different types of waste. One man's trash is another man's treasure. Maybe you've heard of that before, but that's basically what's going on here. All right. An electric power plant, you're going to have waste heat. You have to heat up water in order to turn steam, to turn a turbine. All right. That waste heat, what do you do with it? Well, you can actually use it for fish farming. You can use it for pharmaceutical plants. You can use it. You've got all this hot water. What can you do it for? You can use it for a greenhouse. You could use it to help run your oil refinery. You can use it for heating up area homes. So you have this heated water that usually is just dumped back into the ocean, but hot water is huge for different things. We can just pump that out and basically reuse it. At the oil refinery, stuff that would be normally thrown away, like a sulfur surplus, could be turned into sulfuric acid or drywall. All right. At a pharmaceutical plant, the sludge that would normally just have to be disposed of can then, like I said, with the algae, could be turned into something that local farmers could use as fertilizer. All right. All these different things. When you have an electric power plant, you create ash when you burn coal. Oh man, you just usually have to get rid of that. And sometimes it can be a huge disaster. Like the ash can just float down and get into waterways. But guess what? Cement manufacturers need ash in order to make their concrete. So using the waste and then having a sustainable resource instead of having to go out and mine all this stuff, this is a form of recycling and reuse and reduction all in one, using waste from giant processes to be the fuel for other processes is very real, very doable, and it's happening in many places, but it needs to be done in more. And that's it on this section.